Let's take a look at one-to-one and inverse functions. A function is one-to-one if different inputs always correspond to different outputs. For example, let's take a look at the function f of x equals x squared. We can think of two different x values or inputs that give us the exact same output. In other words, f of 3 equals 3 squared, which is 9, and f of negative 3 squared, equals 9. So we have found two different x values that give us the same y value. So this one is not one-to-one. Let's take a look at 2x minus 1. Now for this function, we could continue to pick different x values, but we'll never find y values that are the same for different x values because this one is one-to-one. For this line, which is lying right here, for any x value that you pick, you're going to get just a single y value when you jump up to that function. And there are no other x values that are going to give you that same y value. So this lends itself to this idea of being able to come up with a graphical explanation. We call it the horizontal line test. For every horizontal line that crosses the graph of some function, it's going to hit that function at most just one time if it's one-to-one. So here's our function. We had 2x minus 1, and for this one, no matter which horizontal line you draw, you're only going to hit that graph of that function just one time. If instead we graph the function x squared, that's really x minus 1 quantity squared, and when you draw horizontal lines, you're hitting it at multiple places. So in other words, there's multiple x values that are going to give you the same y value. We can do this with any polynomial where he's got multiple curves occurring, and any of those that have multiple x values that give you the same y value. So this one gives you this value, this guy over here gives you that y value, this gives you that y value, and this x gives you that y value. So therefore it fails the horizontal line test, and this one is not one-to-one. This one is one-to-one, and this one is not one-to-one. Notice there's different ways of writing that, 1-1 or in the words, either one is correct. One last thought to leave you with is the inverse of a function. And for us, our main point here is to take a look at this notation and to see that when you have a negative 1 exponent here, when it's sitting inside this kind of functional notation, this does not mean 1 over x. This means the inverse of f. And also, something else to think about is that, remember back when we were doing bubble and arrow plots, and we drew arrows to list relationships. We could have the domain here and the codomain here, and we switch those so you get the 1, 4, and the, sorry I forgot the 9, and the 9, and then we reverse the arrows and say we're going to go in the other direction. So in other words, we were going this way, now we're heading back again in this way. The inverse of functions are only possible when you have one-to-one. And so, if you recall, our bubble and arrow, when we had two values that went to the exact same value in the codomain, that in that case we had a function, but now we do not have a one-to-one function. And so we're going to do more of that in the next video where we work with these inverses algebraically.